Sounds good. If it's okay, guys, we're going to record this because we think, again, this would be beneficial for other people later, so we can have the recording on our website later for everybody to see. Yeah, and hopefully this time Zoom will actually record. We've tried this a couple times, and it seems like Zoom really doesn't like us, but hopefully it likes us today. Can probably get started. All right, since everybody's on and early, we can probably get started. Actually, before we get started, CJ, you want to introduce yourself as well? CJ is also on our team. She's on the call. She's not here with us, but yeah. Go ahead, CJ. She might not have the mic on. All right, she probably can't hear us. I'll get started. Welcome to our webinar. Today's webinar, we're going to talk about Python, and especially Python for data engineering. So I know Python is used for a lot of different things, so I want to really set that clear that this webinar is going to be very focused for Python for data engineering, which is actually, I think it's the #1 reason that Python is used around the world for data engineering and data science. And so a little bit of overview for today's webinar. We're going to take a quick step back, maybe 2-3 minutes, just 2-3 minutes. I promise that. We're going to talk about data engineering as a whole. What is data engineering? A lot of people, because this webinar is kind of made for the public, some people might not be familiar with data engineering. And then we're going to dive into the Python part. So we're going to talk about why Python for data engineering, why is it so popular? And then really get to the meat of the webinar quickly, which is around, let me see, there's one question here. We have the chat open actually on the back. All right, when is really how to get to know, how to start learning Python, how to use it, how to set up your dev environment, how is Python used on the cloud. And then Guy is actually going to show you guys the hands-on demo. So we're going to get right into it. We're going to show you some of the tools that we use a lot and how we use those. And then at the very end, I'm going to briefly talk about DataStack.Academy, which is our course for data engineers. So we hear data is everywhere. We hear data is the future. And when we hear data, there's two terms that are pretty much synonymous with data these days: data engineering and data science, right? And we've all heard of those two things. But what is the difference? That's the question we get asked all the time. It's what's the really difference between data engineering versus data science? And there was a really good blog by Monica Rogati about a few years back, and she laid out this pyramid of data needs within a company. And when you look at this pyramid, the bottom half of that pyramid, so the bottom 4 steps, which actually take about 80% of any data scientist or data engineer time, is all data engineering. So the process of collecting data, storing it, moving it to the cloud, cleaning it, making it ready to be analyzed is all data engineering tasks. And then the top half, really, making the analytics and making the machine learning models that draw insights out of that data, is data science. It's more data science task. And really quickly, the other kind of difference here is that typically data scientists in a company work on a very small subset of the data. They work on prototypes. They build a prototype. So they might take only 1,000 users, a small subset, and build a model, build a machine learning model on that sort of prototype environment. but then it's data engineering task that takes that prototype and productionalize that. So it's data engineering task that takes, again, that small model and then deploys to all the users and make sure it's live, make sure it getting the data live, make sure it refreshes and sends all the results back to the users typically. So why is data engineering so hot these days? And it is, data engineering is the fastest growing field in tech. And it's not just me. There are very big reports out there that are saying this. So the top number is from Butchworks, and they interviewed 320 companies between summer of 2020 to summer of 2021, so middle of pandemic. And 81% of those said that they hired data engineers that year. So that's huge. Again, middle of pandemic, this was the top field, and we can even argue the top field, aside from making toilet paper, probably was the top field that got jobs in pandemic. On Indeed, and this is live on Indeed, a lot of these resources, a lot of these numbers will be sent out. We have them in the footnotes, so you can actually go to the sources of these. But you can go yourself to Indeed and see that data engineering has the highest average salary in tech. It's 119. It's higher than data science. It's higher than full stack developers, web developers right now. And there's 40,000 active jobs on data engineering out there on Indeed right now. The last number I'm going to mention is, I think, the most important one. This is from Dice report. So Dice, they analyzed over 6 million jobs out there in the market, 6 million, again in 2020, in the middle of the pandemic. And data engineering was the fastest growing field in tech with 50% growth. Far faster than anybody else. And again, we're going to link the Dice report. You can go to that report on slide 15. That's where this statistics is from. And the other interesting thing there was, well, first, Python was #1 skill on that report for data engineers to learn. And the other interesting thing was a lot of the cities, the fastest growing cities in US that data engineering popular. And it wasn't the traditional like SF, Silicon Valley, New York. You saw a lot of like Midwest cities. You saw like, I believe Columbus, Ohio, like even Jacksonville, places in Florida. And that shows that this field is being remote now. It's being done remote. People all over the US or the world are doing this. And it's not, really focused on those major tech hubs like Silicon Valley and New York. The last number there is actually from Indeed. It's listed on Indeed data engineering. I don't know what it means, so don't ask me. Unlimited time off. That's I kind of know what it means. It's kind of true, but yeah, it's there. So why Python? Why Python is the #1 skills to learn? And the image here that I have on the left is from Stack Overflow. So Stack Overflow did a survey in 2020. So this is again a recent-ish survey. And Python was the #1, 30% #1 language, popular language. And it almost doubled JavaScript, the second one on the list, which JavaScript language used, for a lot of web development and a lot of app development these days, even a lot of desktop development these days, with Electron. And I don't know if you guys know Stack Overflow. Stack Overflow, I'm sure everybody's familiar with it, but it's the #1 website where developers go to troubleshoot problems. So when they have problems, they ask other developers, and you can engage and answer those problems. And why is that? What I think, in my humble opinion, I pretty much know all the programming languages, so I've had to know them over my career now. I gotta say, I do like Python the best. It's the language that I use all the time. I loved it the first time I started programming it. I just fell in love with it immediately because it is very fast and easy and intuitive to learn. And when you're learning programming language, it has all these like brackets and parentheses and the syntax. Python doesn't have that. Python is just so clean. The way to write clean code is the syntax, and it reads English, so it's very intuitive again to understand and learn. So as I would say, as a first programming language, 100% absolutely recommend it as like to be your first language.
Yeah. Can't trust that enough.
Exactly. And what we say is, and this is like I think a thing of the modern languages is these package libraries and the availability that Python and Node.js, another very popular programming language, both provide that. And it's because in programming language, you in any programming, you immediately see that you're not the first one who sees a problem or encounters a problem. People before you have solved the same problem, and they have packaged a way to solve that problem and have uploaded to the internet, and you can download and use that immediately without having to redo that work and reinvent the work. Python has a very good package management software called PyPy. So it's very easy. With one command, you say pip install, and you can use anybody else's code immediately. And that's very, very powerful. A lot of Python and a lot of data engineers and data scientists use that because it makes them much faster to develop, and it makes them much more efficient. I use that all the time, every day. And the last reason I want to say is Python is everywhere. It's very lightweight. You can run it on the cloud, you can run it on your machine, you can run it in a container, in a Docker format, which we talk later. It doesn't have a compiler, so it's not clunky that you have to compile your code, ship that. It's just a script. It just runs everywhere, and it's very lightweight in that sense. And pretty much there's an SDK for any technology out there in Python. All the cloud vendors, Python is probably, I would say, if not their number one SDK, it's always there on the top 3 based on the service that they provide. But it's always up to date. And I can say this because I know how these cloud vendors develop. Like the cloud vendors, they all have a command line interface. All those command line interface are developed in Python. So anything that these cloud vendors can do, anything the services they provide can do, and all the newest features, because their command line, themselves use it, their Python is always up to date. They maintain that, and it's capable to do anything that they can do, because again, it's used even by their own tool, by their command line. And Guy is going to show you guys this in a little bit. Just quickly on the demand of Python out there. Again, I told you it's the #1 skill listed on that DICE report. Over 6 million jobs they analyzed for this. It's the #1 skill listed. As you go down the list, you can quickly see the other data engineering topics that are very interesting. And I show you at the end that DataStack.Academy, we're highly focused on this list. We're highly focused on the cloud. I cannot express enough, if you're learning these skills, learn them on the cloud. So SQL, big data, all of those things. The other thing to notice here on Indeed, you can see that learning Python, just learning Python itself, it's going to boost up your salary by 7%. And there's over 2,000 of those data engineering jobs that is specifically this Python as one of the required skills. I say that number should be higher. Probably the other ones don't list it because it's kind of given. You're gonna be a data engineer, you gotta touch Python. That's the sense. Where to learn Python. This is the meat of the webinar. This is why we're here. There is a wealth of information out there. I'm not going to list all of them to you. If you Google search, you're going to find a ton of them out there. We're not going to list this. We're going to list some of the ones that you might have not known that we think are very, very good. Of course, YouTube is great. If you're someone who learns well and sort of instructor in a video learning environment, YouTube is a great resource. We list a link here that we think is a really good getting started with Python. They're really good getting started with Python courses. Another one that's not here, I would say, is Twitch. Twitch is a really, really good platform if you want to learn with others, and if you want to learn with others in a live fashion. There are tons of Twitch channels where people learn live and they showcase live. You can do that yourself. I highly recommend that. If you're learning, just go post on Twitch and say, hey, like Wednesday at 8 p.m., I'm going to go through this. Anybody wants to join me? And you see people joining you, and then you can learn with others. That's great. That is what I want to emphasize here. We highly, highly recommend those interactive learning environments. And what we listed here, Kaggle has a really great intro to Python course. They have an intro to data engineering course. They have an intro to pandas. They have an entry to data science. And we listed that here. It is interactive. So right then in your browser, you can code and it's all interactive. You can immediately see the results. So you don't have to install anything. It's the easiest way to get started. Programize is another one. They have a really good starting course there. And the last on the list that I want to highlight is Replit. I don't know how to pronounce this, so please, if anybody is from Replit or Replit is on there, I apologize, but it's a great tool, again, for interactive learning. It's where if you want to learn with a friend, and I highly recommend that, like in a programming way, you can both sign up. It's all web browser based, and you can code together and you can learn together. It's great. Of course, we're going to talk about DataStack.Academy at the end. We have a course, we have a Python course. Ours, I would say, it's a lot more kind of high level and depth, and the other things above, because we really want to dig deep in Python for data engineering. And I'll show you guys at the end where you can actually get started free on us. I cannot emphasize enough that start building your GitHub portfolio. So when you're learning everything you do, make a project, make a Git project, post on your Git project. And that's because employers everywhere now use GitHub as a way to vet their resources, the people they want to hire. So start building that portfolio, show that you've coded, show that you know these things. Code never lies. When I hire, I have a consulting company on the side as well, a data engineering company. I strictly use GitHub. I go and look at your people's portfolio. I look at their code, again, because code doesn't lie, right? It's as simple as that. And get hands-on. Use tools like, again, Kaggle is a great tool. They have a lot of data sets out there, a lot of projects, a lot of open projects, real-world projects. DataHub.io is another one. Go on there, download these projects that are available to you, download the data sets, get hands-on, solve those problems, put them on your GitHub profile, put them there. Last but not least, before I hand it off to Guy here, before I talk your ears off, guys, I'm sorry. I think this is very beneficial. I want to go through your learning paths as a data engineer. Data engineering is the fastest growing field out there in the market. How can you become one? How can you get into this market? How can you get a job in this market? No matter what path you choose, the self-learning path, or I'm going to show you this other path, the bootcamp path, start preparing for these cloud certifications and learn on the cloud. Cloud is the way of the future. All the cloud vendors out there, Azure, AWS, Google, GCP, Google, my favorite right now, they all have a data engineering certificate, associate level data engineering or data architect certificate. On their website, they list resources or a learning path. A lot of that is free for that certificate. That's a great place to start. Again, when you go there, build your GitHub portfolio. Go on Kaggle, DataHub.io to get your hands on real world projects. There are a ton of good free resources, like I mentioned, YouTube, Twitch out there, just Google itself. There's a lot of paid courses to get you ready for these certifications on Udemy, DataCamp, Coursera. Those are great. They're low cost. They're typically from $300 to about $1,500 range. But then there's Bootcamp. Before I get to the boot camps, I want to say the self-learning path, it's great. A lot of people can use it. My tendency or my recommendation is it is a little bit more geared towards people who are already in tech or have a foot in the door. it is easier for people who have a foot in the door to kind of level up their skills and then apply for that next level tech jobs or data engineering job. If you're lacking that first step, that foot in the door, then I think bootcamp is a good way. And there's few reasons that bootcamps, these coding bootcamps where you go spend 3 months in a very focused curriculum, few reasons those are they have better results. It's because it's declared intention. And I say that with anything, self-learning path or anything, you have to declare intention. You have to say, this is what I want to do. There's something magical happens when you just dedicate yourself like that, right? And bootcamp is, by definition, it is called a boot camp. You are going to dedicate yourself, right? But it's self-learning path. You have to do that as well. You're learning with other people as well. So you're in your co-learning environment, you're forced to co-program with your people with your own peer, your own level. So again, something magical happens there. But the last but not least, that is very hard to replicate in a self-run environment, or if you don't have your foot in the door, is the career services for these schools. Because they're more one-on-one, there's only a limited number of students. These bootcamps can actually, it's in their business kind of plan to help every person with career services, to help them tailor their resume, to help them better themselves, to be ready for the job market. In our bootcamp, you see at the end, we have a mandatory internship. So we will place you in an internship. We get you that foot in the door at the end. And the online resources, they just cannot do that. It's not in their business model because they sell a little to a lot of people. So the profit margins are low for per student, and they just cannot offer that career service to everyone. And at the end, the secret path to become a data engineer, I'm going to lay, I'll give you guys this at the end of the webinar, so I'll make you wait for this. But at the end of the webinar, I'll give you a secret way where you can land your first job as a data engineer in this market. With that, I will shut up and let Guy take over. And
thanks, Parm. So we'd like to give everybody a little bit of a hands-on demo for about 20 minutes of Python and a Python working environment and some closely related tools that we as engineers use day in and day out on a daily and hourly basis. So let me give you a brief overview of what that demo is going to look like. The first thing is we'll show you a working Python integrated development environment, or IDE, the software that we use to write code, test code, integrate with our other tools. We'll look then at virtual environments, which are a tool that working data professionals use all the time because it's common when you're working on multiple applications that you might have conflicts between different versions of Python, the interpreter, or of your package dependencies, and you need a way to manage those. So virtual environments let you do that. We'll look at Jupyter notebooks, which are something that have become completely ubiquitous for data professionals. These are these beautiful self-contained notebooks that let you package code side by side with comments and other links and images and other kind of multimedia elements to make a really, really nice professional presentation for whoever you have to hand off your code with and collaborate with. We'll look then in a little bit of detail at Pandas, which is a very powerful Python package for doing data reading, manipulation, writing in different formats, which is one of the absolute core tools in Python that data engineers, data scientists use all the time. This is something that if you're doing work as a data engineer, you will use this on a daily basis. And then at the end, we'll look a little bit at Python on the cloud, and particularly BigQuery, which is the Google Cloud integrated database and data analytics engine that's optimized for big data transactions. We'll take a look at what that looks like and an example of cloud functions in Python running on the cloud. So let's get into the details. So I have my my Python development environment up here. In our course, we recommend Microsoft VS Code. That's what we're looking at right now. So this is our IDE, our development environment window, with an example of a Jupyter notebook up. So you can see that a Python a development environment gives us a lot of the tools in one place. We can look at files, we can look at code. I'll show you in a little while how we can run code interactively in these notebooks, which is one of the great features. So this is when you're working as a programmer, as a data engineer, an IDE is where you'll be spending a lot of your time. And that's one of the things in our class that we focus on is those resources and how to get you up to speed on that really quickly. One thing Parham emphasized, and I want to re-emphasize that there's so many resources, so many amazing resources out there for learning anything technical, and Python especially because it's so common. And my experience was when I started learning Python 15 years ago and started learning SQL and programming almost 20 years ago, it was a little bit of a struggle sometimes because there weren't as many technical education resources available, and I had to do a lot of the work on my own. And now there's a lot of things that make it really, really fun. And I'm just going to give you like a brief, just a brief example of this. So like Parham mentioned Kaggle. So we've got a couple of different things here. Kaggle has these great interactive browser-based exercises and tutorials for learning Python. You don't even have to install anything. You can just go and start learning and writing code in your web browser without installing any software. There's a lot of sites like this, Kaggle, Programize. Replit has a full in-browser IDE, so you don't even have to go install any other software to get an environment like this. So take advantage, whatever your learning path is, take advantage of those free resources because there's so many of them out there, and they make it fun and easy to learn. So that's a first look at Python, what a development environment looks like. And so let's talk a little bit more about these Jupyter notebooks, which is what we're looking at right now in this format. And this is something, again, that if you're a data engineer, data scientist, this has just become one of the absolute most standard tools of the trade because they're such a neat tool. Jupyter notebooks let you package code along with comments and other images, links, and format them neatly and package your code along with a story and a narrative that helps you explain either how your data pipeline works that you're handing off to somebody else if you're a data engineer or a data scientist to package your analysis and to give that to decision makers. So Jupyter notebooks use this really neat, lightweight formatting language called Markdown, which has become really common in a lot of tools like GitHub. The web interface for Git uses Markdown heavily. And Markdown is this really cool, lightweight Markdown language, formatting language that lets you do things like unordered and ordered lists, link formatting, different kinds of quotes, code blocks. And you can see here this really easy syntax for doing formatting, and that in notebooks and in other places, this automatically gets rendered into what you see, whether that's in HTML or in your IDE like this. And so these notebooks are something that we teach upfront in our course, that we emphasize a lot throughout the course and use as a teaching method because they're amazing for coding and doing code, and for collaborating with other people that are working on code, and for passing along your results. So this is something that you will use all the time as a data engineer. So the next tool we want to talk about a little bit is what's called virtual environments. So if you think about it, when you're a data professional or programmer, a lot of times you might not just be working on one project, or like when we're teaching in our course, for each different chapter and each different episode of our course, we have different requirements, different package requirements. And so when you're doing that kind of work where you're working on a lot of different things and a lot of different applications, you quickly might run into conflicts between different versions of the Python interpreter or of your package dependencies. So virtual environments are a tool that we use in Python that lets us manage those different versions without running into conflicts, and that makes it just really easy to manage different working environments at once. So that's another thing that we highlight early on, and that we make good use of in our material that data engineers and data scientists use on a daily basis.
Can I jump in?
Yep.
Before you do a pip install in Python, make a virtual environment. Every time you
this has become it's like if you get in the habit of doing this will save you so much time and trouble if you know how to work with virtual environments, and you're not, because if you're installing packages to your system, you will run into conflicts with versions. And so that's why we emphasize using these, is to just make it easy and avoid some of those problems that a lot of people run into when they're not aware of using virtual environments. So the next thing we want to look at is what's called pandas, which is one of the core kind of scientific numeric computing libraries in Python. And it's especially important for us as data engineers because it provides a lot of the tools that let us read and explore and manipulate and write data in a lot of different formats. And pandas provides a lot of tools that make things that in other languages or in other contexts would require a lot more code or be a lot harder, Pandas makes those things easy. And this demo will also give you an idea of how cool notebooks are, because we can run some code interactively and look at the results together. So what we're going to do is just walk through kind of a basic short version of the process of reading some data, doing a little bit of manipulation and exploration on it, and then writing it to a different format. So I have some spreadsheet data here. This is some data that we use in our course that's about some airport data. So this is a spreadsheet with a few thousand records. So we're going to use Pandas to read this in and take a look at that data and try, do a couple of things with it. So here you can see one of the super cool features of Jupyter Notebooks is that you can run code interactively. Like I can run this Python code block and see the output inline in my notebook in real time. So when Pandas gives us this read CSV function that makes it really easy to read data in from a comma separated value formatted file. And we're specifying here with the second parameter that the 0th row, or what we usually call the first row, gives header information with our column names. So Pandas automatically handles that for us and reads this information into columns and understands the column names, and already has this data in an object called a data frame that gives us a nice structure for working with data. And if you have any experience with other languages, you probably have some intuitive sense that if you were doing this in any other language than Python, this would probably involve a for loop and many lines of code. There would be a lot more to this than just a single statement. And this is why Python is just the language of working with data, because it gives us these amazing, really concise and expressive tools that let us do this and make it easy and make it fun instead of being tedious. And this is one of the utility functions, the head function that Pandas gives us that makes things even easier, which is it gives us this nice, by default, it shows us the first 5 rows of our data set. And we can see, there's airport names, latitude, longitude. This is the information that we read in from our spreadsheet. So Pandas, when it reads data in it, it reads it into an object internally called a data frame. And data frames are 2-dimensional structures, which means they're organized into columns and rows. And that 2-dimensional structure reflects the tabular structure that's really common in spreadsheets or in database tables, which is the way data is typically organized in MySQL or Microsoft SQL, or I'll show you BigQuery, that data is usually organized in tables that way. So Pandas automatically uses that 2-dimensional data structure, so it makes it really easy when we're working with data to then immediately go write it to any of the common database tools, because it's already in that format. So databases or data frames have a number of these associated utility functions that are really great and really informative. One of them was the head function that we already saw. Another one of them is this info function that Pandas has built in. And this gives us additional information about this data frame that we've read in from our spreadsheet. So we can see information about the columns and how many columns there are, the names, the data types that the columns hold. The info function even shows us the memory usage of our data frame objects. So this is like one simple function call that'll give us a lot of information. And as data engineers, one of our biggest tasks is there's all this data coming and we might be ingesting it from different sources. And one of the biggest skills is to know how to quickly understand the structure and the content of your data and how it's organized and how you're going to work with it and manipulate it to get it into the format that you or somebody else need. And that's why Pandas is such a great tool, because it's built around providing those tools and making it as straightforward as it possibly could be to get all of these kind of informative views. So the info function is another example of one of the Pandas utility functions. And then another thing that I love this is there's a Pandas package called Pandas Profiling that makes it even easier to get just an amazing amount of information about your data set. So you can run these profiling reports, and you see this shows up in HTML format, again, inline in our Jupyter notebook. So we can work all in one place and run code interactively and see the results. And these profiling reports, you can see, give you an overview of your data, number of variables, information about missing cells, this sort of thing. It gives you a breakdown by individual columns with additional information about distinct values and missing fields. It gives you this detailed breakdown of actual values and the histogram of that by column. It gives you some information about statistics and correlation, interactions in your data, missing values. This is just, again, something that we can run one command in Pandas, do a quick install of a package and run one command in Pandas and immediately get this beautiful, visually appealing report on our data that, again, if you working in anything other than Python and Pandas, I mean, this would be something that in other languages you might spend hours and hours on to generate. And this is something that we can generate in 30 seconds.
Days, maybe.
Yeah, days, literally. And so it's having these tools at our disposal, and the Python ecosystem and the pandas and all these packages makes it easy to do things that, you know, wouldn't have even been possible a few years ago. Companies are working with such large volumes of data now, and the demands are really high. And so a specialized set of tools is needed for that. And so that's why we focus heavily on Python and Pandas and on these things, because these are the day-to-day working tools for data engineers and data professionals. So this is just the end of my report here. So then what I want to show you, the last thing on pandas is, because this is very common lifecycle with data, we're going to read some data in, we're going to manipulate it, and then we're going to write it maybe to a different format. So it's like we read in some data from a CSV file, we did a little bit of manipulation, data exploration and manipulation, and then let's say we want to write it to, we need it in JSON format, which JSON is a common format for, it's called JavaScript object notation for packaging data like this. So you can see now that we've written this from pandas into a JSON file, and this data, the content is the same, but the formatting is different. And again, pandas makes this just super easy, because there's a to_JSON function that we give a couple parameters, and it handles all of the details, so we don't have to do that. And it makes these kind of tasks just really trivial. You can get so much done in Python and Pandas. And again, it makes things that might be tedious in other working environments really fun. And that's why so many people, as Param said, you know, my first experience learning Python 15 years ago, when I didn't have a CS background and I didn't have like a formal introduction to programming, was that it just made intuitive sense to me, and it was an expressive way, a way for me without knowing a lot of technical details to get started in programming. And that's, a lot of people have had that experience, and that's why Python has just become the language of data in the last decade, in the last few years. So now we want to turn a little bit to the cloud part of data, because that's a huge part, as Param said, of if you're working as a data scientist or data engineer, cloud has become the working paradigm. So that's a skill that, you know, we emphasize that employers look for very heavily. And there's Pandas gives us tools for working with data on the cloud. One of these is, here's an example of a function, this Pandas GBQ function, which is the GBQ is referring to Google BigQuery. So BigQuery is Google's unified database and analytics engine that's optimized for big data, high volume transactions. So provides a lot of the tools of a standard relational database, but then takes a lot of the administration details off of your plate as a developer, and makes it really easy to work with large volumes of data. So you can see here that Pandas gives us this easy function that writes data to BigQuery, and I'll show you real quickly the BigQuery console here. So one of the cloud tools when we're working on the cloud is BigQuery. The Google Cloud products all have this great web UI for accessing all your tools. So from Pandas, I've written my data to BigQuery, and now we can go in here and see that I can easily access this data on the cloud from the Google BigQuery console. And we can see that the data that I read in originally from my spreadsheet and did a little bit of manipulation on now has been read into my BigQuery table. And we can work with this now that this is on the cloud, we can use this in pipelines in any number of ways and interface this with many of the other Google Cloud services. So BigQuery, one thing I want to highlight about this and about cloud services in general, BigQuery is a good example of what we call serverless cloud architecture. And what serverless means is that a lot of the normal details of like administration, like dealing with server addresses and ports and things like that, are completely managed. You don't have to deal with those as a developer. Those are all handled by the cloud vendor. So BigQuery is great, and we teach this and we use this a lot, because a lot of the things that, like when I started as a database developer and having to do a lot of database administration, a lot of my time was spent doing server configuration and those sorts of tedious things that were not just building my data structure and working with my data. So these serverless cloud services make it really, really just so much easier, so much more straightforward to get started and to actually spend time working on the things that you need to work on instead of doing a lot of tedious administrative things that probably aren't that much fun anyway, that could easily be somebody else's job. So while we're looking at this too, we want to highlight one more aspect of Python on the cloud, which is another example of serverless architecture is what's called cloud functions. And we just wanted to show you the landing page here in the documentation. Cloud functions are an example of another serverless architecture product. And they're these great single-use functions that you can attach and be triggered by other events and have them do pretty much anything. So like an example of this that I think we've probably all seen and used is like a website where you might go and upload a PDF or some kind of other file. And as soon as you upload the file, it automatically gets processed in some way. Maybe it's doing text recognition, and then it gets maybe moved into an archive folder. And like what's happening behind the scenes there usually is when you upload the file, it goes into a storage bucket on Google Cloud or some other vendor. And then there's one of these cloud functions that's run that triggers your processing and further handles the file. So you can see in the cloud functions documentation here how much a part of the data ecosystem that Python is. I mean, it's really like the glue that holds a lot of these pieces together. Like, you know, Google in their documentation, they support Node.js and these other languages, but Python is absolutely the language that when you're working as a data engineer or data scientist that you will be using the most on a day-to-day basis. And all of the cloud vendors support Python first and foremost, because that is the language that data professionals use. So that I think concludes the hands-on portion of our demo. I hope that's maybe given everybody a little bit of insight into what it's like to work in Python and some of the tools that we use. And I'm going to kick it back over to Parm now so he can give you a little bit of wrap up.
That's great. Thanks a lot, Guy. That's incredible. Thank you. So just quickly, I want to now kind of focus on our course, DataStack.Academy. We have a bootcamp for data engineers. It's a 20-week long lecture bootcamp. At the end of that 20-week, like I mentioned, you actually have to mandatory do a 5-week internship. We'll replace you at a big data company, a lot of very big companies that we have relationship with, and you will work there, so you'll have some real world experience. If you want to know more, go to DataStack.Academy. That is a URL. .academy is a new URL. If you don't like that, you can also go to DataStack.Academy.com. It'll kick you to the same place. And you can actually get it started for free. So we have a full-fledged Python and SQL course. It's supposed to, when we teach it, it's supposed to be, I think, about 4 to 5 weeks for those 2 chapters. All of that is free. You can, there's a link that says get started for free. So if you click on that, we will send you a link to the course. You can go through it yourself. This is what we will teach. It's a great place to build your portfolio, because in those 2 chapters, the Python and SQL, I think we have like 15, 20 different exercises. We have like 3 full-fledged projects that you will do.
Daily and weekly project material that'll give you the hands-on introduction that you need to get up to speed quickly. Yeah,
and to build your portfolio. There's tons of other resources there. Our cohort is going to start January 3rd. If you're interested to joining, there's all the information on the website. If you need to talk more, please do talk to us. Me, CJ, everybody's available. I think there's a link there to actually put a schedule on my calendar to talk to me directly. Please do. I would love to talk to you. We think this is a great program that will definitely prepare you to get a job. I mean, if the internship, it comes guaranteed, right? The curriculum that we have up, I'd like to quickly mention this. And I, again, humbly say this, and I've studied everything that's out there. We've spent about 2 years developing course, Guy and I, and other people on our company who's spent developing this, and all of us are well-seasoned data engineers, data people.
I think between the three of us, we have at least 60 years of combined experience working in the data industry.
And then this is, and again, I humbly say this is the most comprehensive course that I know out there in the market. And I've studied about, or I've studied about all of them to see what they offer. I'm not gonna lie to you, it's very intense. It is very intense. Data engineering in some ways is intense. It's an intense career. And you have to learn a lot. You have to dedicate yourself. But if you dedicate these tools, you will definitely have a job. What I want to mention here is our cloud first mentality. Again, as you see, when we teach you a lot of these open source, a lot of these common technologies, we will teach you them on the cloud. We've chosen Google Cloud for our course, and that's because all of these technologies, the cloud vendors take those and then they slightly change them, they rename them, and then they offer them to their as a service. Google Cloud is the one that's closest to the open source. They've nearly not changed the underlying open source technology. So when you learn this on Google, that knowledge is a little bit more easier transferable to the other clouds. Then you can go to the other clouds and transfer your knowledge there. So that's why we chose Google Cloud. They also offer you like a 300 cloud credit to anyone who starts, and that's more than enough for our course and more than enough for you to get started as well. So we highly recommend that. I think that concludes our webinar. Again, we invite you to go to DataStack.Academy. We will send you the slides from today. We will also send you the Jupyter notebook that Guy showed. So that has all the links that we talked about. You can easily open that in VS Code or open that in any environment that you have and follow along. That's it. Again, we have few people, so we would love for you guys make this as interactive possible. Please feel free to go off mute, ask us questions, tell us if this was informative. Hopefully it was. Tell us if it wasn't and how we can make it better. We love to hear from you guys.
Thank you so much. That was great.
Thank you for tuning in.
Yeah,
glad to have you here. We're really excited about this material, so it's good to start. It's good to start seeing some people, putting it in front of some people and making some connections. So
for sure, I've already signed up for the free course, so I'll see. Thank you.
Awesome.
Great. Yeah,
awesome.
that first two chapters it'll give you a great preview. I mean, those first two chapters are our material on pandas and databases and SQL. So that'll give you kind of an idea of what to expect with the course, and it's also just the content is really good. You can learn a lot from that, so definitely check that out.
I see a question from Eli. Can you walk us through DataStack.Academy, how to get started? It's fairly easy, but I think I can actually log in. So if you go to DataStack.Academy, over here, some of the links I like to demo to you guys. Right on top, you have everything that you would need. If you scroll down, this left-hand menu will take you to the relative information. So the information about our bootcamp, the internship, the tuition for this bootcamp, the curriculum. The getting started is probably where you want to go. If you click on this link, the get started for free, just sign up with your email, your first name and email. We will send you the instructions to get those two chapters to the Python and SQL chapter, and you can set it up. It's actually on GitHub, so we invite you to go directly to GitHub and go there, and you get all the instructions there. Again, it's about, I think that the Python and SQL is about a 5-week. When we teach it, it's going to be roughly 3 weeks of instructions, but that is added on with projects and exercises, so it will take about 5 weeks. Register for webinar. This is a great link. If we have other webinars, upcoming webinars, you can see our schedule here. We would have a webinar on GCP, I believe, on Google Cloud specifically next week. We have a webinar on Docker the week after that. That's another very widely used tool, Docker and Kubernetes. I think that one is actually getting a lot of signups. So we invite you to go there. Schedule a call to talk to me. This goes actually directly on my calendar. This link, it's a Calendly link, so you get to pick a time on my calendar, and I would love to talk to you one-on-one. Ask me any questions that you would have. And last but not least, there is an apply button here. So if this is a course that you feel this is a course for you, you would like to dedicate yourself, you like to become a data engineer, click on this link, register. Again, our course would start on January 3rd. So there's some time left, but there's limited seats, and Guy will be your instructor. Yeah, I think that's it.
And Adrian, thanks. I see you said that you've gone through the free material. Yeah, that's we're excited to provide that to people, and that'll give you a preview of the course. And it's just that we put so much time into developing this. So yeah, there's a lot of good resources there, and that's still, we're in the process of still beta testing, getting further feedback and refining that material. So it's a lot of work has been put into that. So we're glad that you were able to take a look at that and get something out of that. Thank you.
I see CJ say, did you guys see the part when I showed the screen with the data stack stuff, or you didn't see that part? We're in tech, but tech always fails us. Even being in tech for how many years, it doesn't help. Did you guys see that by any chance when I viewed the DataStack site? Maybe a yes or no? Did you guys all drop? I don't hear any.
We're on. Oh yeah. Oh yeah.
Oh, okay. All right.
Great. Cool.
All right.
Yeah, the website should have everything you need. You can get in touch with us. You can look at the free material, and we got these webinars will be a weekly thing that we're going to go next week and into a lot more detail on Google Cloud. The subsequent ones will be much more into detail on specific topics. So if you're interested to see more about what tools we use, like the hands-on demo today, the subsequent webinars will be very detailed in that regard. So we hope you'll keep tuning in.
Adrian, it's great to see you as well too. I see your name, and yeah, just sorry, a little shout out. Adrian and I used to work together, so it's great to see you. And actually, Adrian, the course is provided through Epicodus, so it's familiar grounds.
Any other questions? We're a little over time, but we're happy. If anybody else has questions, let us know. We're here.
Actually, pretty good on time.
Yeah.
Yeah, anybody, please jump in. CJ, are you still there?
I am still here.
All right. You want to introduce yourself? I know you were on in the beginning, but if you'd like to introduce yourself as well, go on.
Yeah, sure. You would normally see my face, but today we're a little bit busy back here at the office. So yeah, I'm CJ Viora, and I am doing the marketing, and I am the person that will be hosting a couple more of these webinars. And I am a person that if you have any questions, you can either talk to Par or myself. It's CJ at DataStack.Academy, and I'll make sure I put that in the chat function too. And I am just, thank you guys so much for being on. It really makes me happy that we get to educate on things that we love.
Absolutely.
Appreciate it, CJ. Yeah. All right. If anybody else, if no one else has any questions, we can give 8 minutes back to you in your day. And again, thank you so much for joining. CJ also posted her email. If you guys need to talk to me again, just go on the website and click on that schedule a call, and that goes directly to me. I would love to talk to you. Thanks again, guys. Appreciate it, and have a good day.
Thanks, everyone.
All right. Now let's figure out if we can stop the recording and share.